Okay, so again, using 3 points, our area can be found plus or minus 1/2 times, and then you have to find the determinant of this matrix. Again, don't try to just memorize the formula, understand how it's set up, and it's a whole lot easier to remember. We have our 3 points in the first and second columns. The last column is just full of ones. The reason for that is that you can't find the determinant of a matrix unless it's a square matrix. So we put that column of ones in. Now, why it's ones, I don't remember. I don't know the derivation of this formula off the top of my head. But it is just ones. So let's actually use it. We have the area equal to plus or minus 1/2, and then we need to find the determinant of the matrix. So notice the points that we're given. We're given the point 1, 0, 2, 2, and 4, 3. So what would one row of our matrix be?
1,
0, 2, 4.
0, 1.
Good, 1, 0, and 1. So here's the point 1, 0, and then the 1 for the last column. Okay? How about a second row?
2, 2, 1.
Good, 2, 2, 1. And then the last row?
4, 3, 1.
4, 3, 1. Okay? Now, the most challenging part of this is simply finding the determinant of your 3 by 3 matrix. Okay? You guys preferred the first method from our vote on Thursday. So let's use that. We'll show the second method as well. But let's go ahead and use our first method here. We had the matrix 1, 0, 1, 2, 2, 1, 4, 3, 1. Then we copied the first 2 columns as a 4th and 5th column. And we did that so that we could find diagonals. We start in the top left. There's a diagonal. And we're going to multiply those. 1 times 2 times 1 is 2. And then we look at the next diagonal. 0 times 1 times 4 is 0. So we're adding 0 plus the third diagonal. 1 times 2 times 3 is 6. Alright, so we have 2 plus 0 plus 6. Then we need to subtract the backwards diagonals. Okay, so we start in the top right this corner. The top right corner this time, we're subtracting 0 first. Then 1 times 3 is 3, so minus 3. And then 1 times 2 times 4 is 8, so we're subtracting 8. Okay. So our determinant equals a negative 3. Well, it doesn't. That's where the plus or minus comes in. Our area is plus or minus a half. Since our determinant was a negative 3, I want to use the minus 1/2. That gives me a positive area of 1.5 square units. Okay? You just pick whichever one will make it positive. Does everyone understand what we've done there? Find the determinant, it's a half of that, you get your area. Alright. Now, just so we can see the other method. Where the other method we used minors and cofactors. Let's look at this real quick. So we would write it 3 times, and then the easiest way, we're picking out the top left corner, we eliminate the rest of that column and the rest of that row, and we have this minor matrix of 2, 1, 3, 1. So we're going to do 2 times the determinant of that matrix. And here's where you could use the fish method. Alright? 2 times 1 minus 1 times 3. So 2 minus 3. Okay?
How'd you do it?
How we did this part? Okay? It's actually just kind of like the previous method we used. You have a forward diagonal that you multiply. 2 times 1 is 2. Then you have a backward diagonal. 1 times 3 is 3, and you subtract the backward one. Okay. Alright, then our middle term. Our middle term, remember, this is the key part. Make sure you subtract your middle one. In this case, it's 0 is our cofactor. Our minor is the 2, 1, 4, 1. So 2 times 1 is 2. 4 times 1 is 4. So we have 2 minus 4. But it is times 0, so it doesn't matter. But just so you can see the process here. We've got that. And then finally, we use this one as our cofactor. We eliminate the first row, last column. Alright, so now we're doing the determinant of this 2, 2, 4, 3. So it's plus 1 times 2 times 3 is 6. Minus 2 times 4 is 8. Okay.
You've given up your desk.
Oh,
That's for you.
Okay.
And then our student is bringing over a paper tonight.
okay,
Okay,
thank you.
so much.
Alright, so this is a -1. This is 0. And this is a -2. So that equals -3, just like we got with the other method. But if you like that method better, you can do it. Okay? Alright, so any questions on the formula itself or finding the determinants here? Anything? Alright. Okay. So here we have kind of a little twist on this application. And that is, what if you know the area you want, but you don't know all of the points? Okay? So for example, we know we want the area to be 12. And we know the point 2, 8 is here. Here's A. We know the point B is -3, 1. But all we know about C is what the y-coordinate is. Okay? Now, if we didn't even know the 5, there actually are an infinite number of points that would make a triangle that have an area of 12. Okay? If we wanted any one of them, we could pick whatever we wanted to be y, or whatever we wanted to be x, and just solve for the other one, like we're about to do.
I just have a question. Does it matter which one is X1 and Y1 and which one's X2 and Y2?
No,
It doesn't matter.
no, it
They're
will
the
make a
same answer.
difference.
Okay.
Mhm. Yeah, back here, the order that you write the points, you know, if you had 2, 2, 1 up on the first row and 1, 0, 1 as the second row, it wouldn't make a difference.
101 is more easier.
So, yeah, it does make it easier on that second method
Yeah.
especially. So, but here's the deal. All we know about C is that it's somewhere along this line y equals 5. Okay? C is somewhere there. Okay? Now, the question is, one of the questions is, how many solutions are we going to get?
2.
What do you say 2?
There's a plus minus half.
That's right. You have a plus or minus 1/2. If we started plugging this into our formula, the area has to be 12. We have that equals plus or minus 1/2 times the determinant of the matrix that we're going to use. Okay? The plus or minus is what makes it possible to have two answers. Also, if you look at this geometrically, I know this isn't drawn to scale, but any triangle can be drawn, okay?
Either on the left side or the right side.
Oops, let me do that. Yeah, it'll either be on the left side, okay, like this. And again, it's not to scale, but, or on the right side like that, okay? So we're going to get two different points, okay? Two different x coordinates for our value of C. And that's because we have what's called a parallelogram. If you've had geometry, you've learned about parallelograms. Here we have the left-hand side and the right-hand side. This line BA would be one of the diagonals. And one of the properties of a parallelogram is that it cuts a diagonal, or it cuts the parallelogram in equal halves. All right? So we have two different possibilities here. So let's come up with what the matrix is that we need to use. Okay? What would one row be?
2, 8, 1.
2, 8, 1, good. And
Negative 3, 1, 1.
negative 3, 1, 1, and
X 5, 1.
there we go, x 5, 1. Now, you can start solving this even though you have a plus or minus there. Okay? We could multiply by the plus or minus 2 and make this a plus or minus 24 equals the determinant. Okay? Does everyone understand that? And you're going to get the two answers because you have that plus or minus 24 now. Okay? So you take it from there. See if you can't solve for x. Use one of your methods for finding the determinant. Try to solve for x.
Yes.
And if it is, yeah, that actually was. Oh, wait, that should be flipped over. what do you guys have for the determinant in terms of x?
1 plus 7x.
Alright, 1 plus 7x, or 7x plus 1. So that plus or minus 24 has to equal 7x plus 1. So really you need to solve this twice, right? If you subtract 1, if it was a positive 24, you're getting 23. If it's a negative 24, you're getting a negative 25. Okay? Then you divide by 7. X is 23 over 7 or negative 25 over 7. Okay? So up here, this would be our negative 25 sevenths, or negative 3 and 4 sevenths, 5. Okay? This right here would be our positive 23 sevenths, 5. Okay? So we got our two possibilities. Any questions with what we've done there?
Can you solve it?
For the determinant?
Yeah.
We have in trouble with the determinant? Which method?
The first one.
Okay. So if I was doing this one, trying to find the determinant, the first way, I'd have 2, negative 3, and x, and I'd have 8, 1, and 5. So now I'm working with my diagonals. Okay, 2 times 1 times 1 is 2. 8 times 1 times x is a plus 8x. Then 1 times negative 3 times 5 is a plus a negative 15. Then on my backwards diagonals, I've got minus a negative 24, so plus 24, minus 2 times 5 times 1 is 10, minus 1 times 1 times x, so minus x. So that's how we're going to get 8x minus x is 7x, 2 minus 15 is negative 13, plus 24 is 11, minus 10 is 1.
Thank you.
Alright, so, again, just a little twist on the on this application of using determinants. Okay, we can actually find a point to make it the area that we want. Alright, so, now, I've given you a couple like this, where you have to solve for x. Note here that even though they're using the variable x, it's the y coordinate. Okay, so then we have a couple others. The first few, you're given triangles. Here on 5 and 6, we have quadrilaterals, so how do we handle those?
Divide it into 2 triangles.
Yeah, cut it into 2 triangles. Alright, so I'm going to let you guys get started working on that with the remainder of our time.